Hi everyone, it's Judy. Welcome back to the OnTrack podcast. Today I have two returning guests to the podcast, some old friends and folks you'll immediately recognize. I have Mike Creeden today and Rick Hartley. Between the two of them, they have over 100 years of man experience in PCB design capabilities, and they're going to talk to you about a new course that is relative to everybody who wants to step up their career and their design game. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hi, Rick. Hi, Mike. Thanks so much for joining us today.
Hi, Judy. Well, good to be here.
Hey, Judy. Hey, Rick. Good to see you both.
You as well, Mike.
I wish we were meeting in person at some fun trade show, but here we are on Zoom again.
There we are.
Here we are. Glad to be here.
Well, I'm really excited to share what you've been giving me some exposure to, which is a PCB design engineering course. And so why don't we start out by talking about this course, the PCE EDU, and why is PCE EDU and not PCB EDU?
Well, thank you, Judy. Love the question. So changing the acronym from PCB to PCE is maybe like trying to move the Rock of Gibraltar. I'm not so sure how easily that would be achieved, but PCB has a term that's endeared to all of us, been around for a long time. And essentially, it is a science about fabrication of bare boards, PCB. PCA is indeed a science about assemblies. But today's printed circuits are really under an umbrella of engineering. They always have been, okay? And that umbrella is essentially from development, architecture, development, schematics, into layout, fabrication, assembly, and into operations. And engineering is essentially the overarching to all of it. And it's really so much more than PCB design as we once knew it. Most anyone performing layout nowadays is an engineer. I mean, there's a lot of designers still doing it. God bless you. We have held this industry down for so long. But as we retire, engineers are stepping into this role. And so it's really much more of an engineering science. What do you think, Rick? Art or science?
Oh, it's definitely science. There's no question about it, Mike. Probably starting somewhere around 30 years ago. At one time, as you guys both know, it was a connect the dots function, and it was more art than anything. I mean, it was really about creating an artwork that could be produced reasonably to make a printed circuit board. But somewhere around 30 years ago, when signal integrity and EMI concerns and other things started to creep into the picture, it really did become more of an engineering function. And it keeps getting more so each year, to the point where people who don't understand the engineering side of it are going to have problems moving forward, hence our educational opportunity that we've put together.
So the rhetorical question, and I've been asked this for a long time, is that you can have science with no art, but you really cannot have art with no science.
That's a good point.
Gotta work.
Very good point.
Yes, and I think one of my favorite photos of you, Rick, is probably back in the early 80s, that one of you doing tape ups on the light table.
Yes.
And it did feel like it was somehow artistic, but technology now has so many aspects. And when you just think about what's in a smartphone, right? Mm-hmm. Devices on top of devices on top of devices, all the noise, the EMI, the antennas, there's so much going on there.
Yep.
Right.
And to manage all that is no easy task.
You know, I was going to say, there's another perspective for the art, and anyone who's served truly as a designer understands that it's a packaging skill.
Yes.
And that type of symmetry and observation for detail, many people call that art. It's really more of a packaging skill.
Yes,
But
it is.
you in today's circuitry, as Rick had mentioned, you have to have the science behind it. You cannot do both or have one without the other.
Yep.
Correct.
Makes sense. Well, so PCE EDU is printed circuit engineering education, right? And so I know you've all put a lot of blood, sweat, and tears into helping co-develop this course. And I like how you've redefined it to printed circuit engineering. That's something we definitely observe here. I think the last study here at Altium was 80+% of Altium customers are electrical engineers. So
Yes.
I think that's really relevant. But something gets lost in that since printed circuit board design is not part of a university curriculum. So, and we kind of throw them to the wolves, as you know, and I think we'd all like to see something done about it. And you guys definitely have said some.
Hence our new course.
Yes, hence your new course.
Right.
So this new course, who is it? Who is it for? Who would be interested in taking it, do you think?
Well, let me take a stab at this first, and Rick, maybe join with me at the end here. So the answer to that question, I'm going to give it to you two parts. I think there's a broad answer, and then there's a very singular answer. Broad meaning basically anybody involved in printed circuit engineering. Okay, but specifically anyone required to accomplish printed circuit engineering layout. Okay, so I think it's recommended really for, an engineering layout beginner. Okay, we're not conferring the title engineer. You get that from a 4-year degree. But what we're acknowledging is those people doing it are predominantly engineers, as you had just mentioned, Judy. And so it could be for any engineer who's really just getting into it, or a newbie just trying to do design. Okay, I believe it could be a refresher for a seasoned professional, because this curriculum also has an optional certification with it. And it'll be available in, both day classes and in evening classes. It'll be taught live and it'll be taught online. So the goal is to truly make it accessible to people. And I can tell you also how it functions a little bit, but Rick, what do you think on who's it for?
Who's it for? Well, I think you hit it well. It's aimed at just about anybody who wants to get involved in the science of printed circuit design, but it's really aimed more than anything at fairly newly graduated engineers who have been conscripted by their companies with the task of doing the printed circuit layout. They create a schematic, they create a circuit, and all of a sudden somebody has to lay this thing out. Well, it used to be the printed circuit designer who was a technician, he was a draftsman, he was whoever that was pulled aside, taught how to read a schematic, taught how to do a board layout, because when it was connect the dots, there was very little science involved. It was a matter of just lay the thing out, and as long as you don't have shorts or opens, it's going to work, it's going to be fine. As we mentioned early on, those days are gone, and that's why a lot of companies are directing young engineers into this field with the thought that those engineers will understand the circuit side of it and won't confuse those issues. But the problem is, how do they know what good manufacturability rules are, what good layout rules are to make the thing function as it should without signal integrity, without EMI, without this, that, and the other kinds of problems? And that's really who it's for. It's for anybody who wants to reassess their educational level, wants to add to it, an existing designer, or for new graduate engineers who are getting into the field.
I want to ask you both something here. Has it been, you both are heavily involved as educators in different ways. So is it your observation while you're out doing these courses that people might be in your courses that have been laying out boards for a while, but maybe there's sort of holes in their training that they might benefit from doing a comprehensive course like this?
Yes. Go ahead, Mike, take that.
The simple answer, yes, is true. Let me add another 3 perspectives to the yes answer. The holes, and we actually determined this a handful of years ago, what is affectionately known as the engineering layout triangle. Whoever's doing printed circuit engineering layout has to address three perspectives simultaneously. And we as a profession didn't do that, let's just say as a job description that well. And those three perspectives is you must solve a very complex, dense layout. At the same time, from that same perspective, you're mastering your CAD tool. CAD tools have gotten very sophisticated. The ease of use is always being, upgraded in a CAD tool, but at the same time, you're adding a sophistication. So you have to master that. You have to understand HDI, how to actually route an HDI board. That's the first perspective. The second perspective, and Rick is truly we're privileged to have him on there, is the performance. Rick is one of the top shelf speakers on this. I mean, Eric, there's a handful of people who do this type of speaking about the signal integrity, but you have to have signal integrity theory and application. So we're going for that.
The third EMI control.
EMI control, exactly. I mean, so again, if we let Rick talk on this, he'll take the whole hour.
Yeah, I'll go on forever, so I'll shut up.
No, I'm kidding. The third perspective is the manufacturability.
Right.
And we build to standards, and these standards are contractual entities that we have to observe, and that's what produces a robustness, which gives you high yield, low cost, and long-term reliability. So those three perspectives, I think, are the holes that our answer yes comes from, and our curriculum is geared every subject to address those three perspectives.
Well, Rick, I have this endearing memory with you. The first time we really talked at any length, we were at PCB West, and you and I were talking about, God, why don't these engineers go to the board shop and learn stuff? And we were kind of commiserating. And you're like, every class I teach here, Judy, I say, go to your freaking board house. I was like, I think there's a course title there. But
no, I agree entirely.
We feel that way, but we also know that's not always a possibility, right? There's not always the budget. There's not the time. I mean, the constraints from when, 30 years ago where we had time and budget to do those things, it's kind of evaporated. So I think that, Mike, to your point of including those things, and Rick, you know this very well because you self-educated. And so to my point, getting back to our conversation here, can you talk about what is exactly in the course, what it includes, so listeners might know what they can expect to learn? And then also talk a little bit about what inspired you to create this course in the first place.
Rick, how about I take that first one, you take the second one? You good with that?
Please do.
All right, brother. So I'm trying to think of how to best describe A to Z with three perspectives. So I'm going to go by a little bit of overview here that I believe that this class will cover fundamentals, okay, all the way from an overall awareness of the profession, okay, just an overarching description of the profession, how to be successful into it, because again, it's geared to be a professional trade manual. And then it will specifically cover stuff like schematic capture, component engineering, those type of things, signal constraints, and when those are applied, truly all the way through the process. It'll go into component placement. And this will be done for multiple different types of circuitry, for a high-speed digital, for RF. We will cover printed electronics. We will cover flex circuitry. All the different aspects. So placement for all the different circuit types. And we'll also get into routing for all the different types, because they're very different. A 50 ohm digital line compared to a 50 ohm RF line. I said 50 ohm, but I said two extremely different things. So there's a lot of nuance to engineering layout, and we really go after those nuances. We'll go into signal integrity applications all the way from the front when we're talking about stack-ups, material selection, and planning and coordination with your manufacturers at the very beginning. and then in through placement and doing, iterative milestones with your supply chain. So in through placement and routing, we'll go into, again, a flex circuit. We have a whole chapter on flex circuitry. We talk a lot about the curriculum is CAD tool neutral, okay? But we speak a lot about how to be a master of your CAD tool without the specifics of any one CAD tool. Right. We basically, I've owned almost every one of them in a past life. So the principles of mastering a CAD tool are true to all of them. And so we're encouraging that, and we're encouraging them to be plugged into, for example, Altium in your Altium Essentials class to be a CAD tool master. It's kind of like learning how to use a socket set. Doesn't make you a mechanic, but you really ought to know how to use the best socket set out there. I see that smile. So into documentation, we cover a lot on documentation because that's truly the handoff. And then what are the required or recommended supports into manufacturing? And then all the way out through testing, compliance, and then into operations, and truly designing for the end product needs, not just designing for what I think is right, but really what does my end user, my end customer want and need in their environment? So I don't know, that's kind of a long-winded answer. Rick, any kind of sum to that, or?
No, I think you hit it. I think you hit it well on the head. I mean, the other question Judy asked is why? And the answer is simple. I mean, since, as you said yourself, 80% of your users, Judy, are engineers, because young graduate engineers and more seasoned engineers are being thrown into this role of printed circuit design. Engineers in college learn circuit theory. They learn how to put together a schematic, how to think about driving device B from device A, how to program it to do this, that, and the other. Those are all circuit theory applications. They learn about voltage and current. The circuit boards, as we know, don't work on voltage and current. They work on fields. And you have to understand the concepts behind that to truly know how to lay out a circuit board to be successful. And as you said at the onset, Judy, go see your freaking fabricator. This course will teach them a lot about the concepts of fab and assembly, things they absolutely need to understand if they intend to design a circuit board that is producible from a bare board standpoint, that can be assembled, that can be tested well and easily and thoroughly. And all of these things all come into play. So that's really where this course is going. As you said, you don't learn this stuff in a college. Mm-hmm. Colleges, to this point, haven't taught printed circuit design. We're hoping to change that too, by the way.
Yeah, we will talk about it, but I would like to share a small little anecdotal story about the typical person Rick somewhat just described. I had the privilege to create and serve as the owner of San Diego PCB Design. And so I got to interface with a lot of engineers. I have never met an engineer that says, no, I can't do that.
Yeah, right.
They don't exist, okay? Engineers are problem solvers. Right. And their managers, they didn't find anybody new entering the design layout. And Rick used the term conscripted to do the layout. His boss said, I want you to do the layout. You're the engineer. And the guy goes, okay. And he started doing it. And he did it, and he built the first one, and then he'd come back to me and said, Mike, you need to help me here because that first board really failed. I didn't understand the challenge of it. I didn't understand the manufacturability of it.
It was hard to build. It was.
Yeah.
That's so expensive and painful.
And there's nobody graduating from college with truly a comprehensive. So we want to address that. And I think you told us you might ask us that question later, so I'll leave that to them.
Well, there's a designer I know and respect, and you guys might know him, Mike. I'm pretty sure you know him. Was Michael Ingham, and Michael calls himself a PCB janitor because he's always cleaning up other people's messes.
That's great. I love that.
We had a similar expression is that we had a cottage industry for recovering engineers doing layout. and our goal is to now empower them because they are the front lines of doing this. And it's just acknowledging that that's the reality of what we're up against.
Well, and I know we have a lot of love and respect and compassion for these engineers that are jumping into the deep end of the ocean and kind of get knocked about the head. I think we're all for that. And because they're not going to board shops or assembly shops or whatever, I really appreciate that you're kind of front loading them with some things they need to know, whether or not they get to do that. And it integrates super solid theory, layout practices with insights on manufacturing. I mean, that's sort of the trifecta. And so this is why I wanted to have you on, and I celebrate with you and what you've done. So I know you two were part of a group that authored this class, and to me, that brings a lot of chops to the table. I know you two have over 100 years in design engineering and layout. Who are the other authors that were involved in creating this course?
It was Gary Ferrari, whom a lot of people know, of course, Stephen Chavez, and Susie Webb.
So I know Steph works for a large OEM.
Yes.
And you guys have been working with him for some time.
Right.
Susie was an artist and became an incredibly talented layout engineer and has worked also for large OEMs. And
she
Gary,
does now. She works for, I won't say who it is, but she works for a large OEM currently.
And Susie also has been, along with Rick and Gary, one of the, I'm going to say, frontline instructors for professional development in the industry, teaching at PCB West and different, Altium Live and different instructional forums. I'm just going to say for a handful of years, meaning that her expertise is,
a few years,
tongue in cheek.
Yeah. And
I know none of us want to admit how old we are. So
they're not all man years. So we got some woman years in there.
We got woman years in there.
Go
Susie.
Right.
We have 235 person years between us.
Yes.
That's crazy. And
that's a lot of
and there was quite a few other contributors to the effort. I would say in the acknowledgement of the book. Can I hold the book up?
You can. Our listeners can't hear, but ones are watching on YouTube.
All right. So those who can see this online. So there it is, the Printed Circuit Engineering Professional. And you can see it is quite thick. It's 400 pages. And it is fully color illustrated.
My goodness, you guys.
A to Z. And when we get back to the back here, there is a seventh chapter that is exclusively developed to signal integrity, EMI, both theory and application. So quite a few placement, routing, stack up, graphs, charts, color illustrations. So, and the acknowledgements in the back of the other contributors.
Well, at the risk of being corny, I am overjoyed, you guys. I want to dance a happy dance because this has been so needed for so long. And congratulations. I know this was a big task to get what's inside of your heads, out onto paper in a digestible format. So this is really great. I just want to.
It has been 3 years in its creation.
Yep.
It's amazing effort, and so happy you guys got that out there. It's so needed. So I noticed in looking at the EPTAC website, that people can sign up through EPTAC, right? I mean, there's a few different ways, but on it says there's an optional certification that will be offered by PCEA, Printed Circuit Engineering Association. Can you talk about sort of the mechanics of how that works?
Sure. I'll take the first stab at that. So the methodology of how the course is, disseminated, administered, is that you can sign up at eptac.com. They have an exclusive license agreement in North America. We are looking internationally because we have some international interest at this also. But EPTAC is a premier electronics professional development instructing company in North America. So we have an exclusive agreement with them for the professional. And what would happen is you would sign up for their course at eptac.com or just call them. And the book, the textbook would be mailed to you. It's in hard copy. There is no soft copy. It's meant to be a desktop. Literally flip it open and it stays on your desktop. You would have, say, maybe 4 to 6 weeks to read the book. And then we would gather either live and in person. There's always a little bit value added when we can do this live. We will also be offering online through Zoom a 40-hour instructor-led review, over 800 PowerPoint slides where we're reviewing and dialoguing the conceptualization and retention of the material. At the end of that, some people wanted to take an exam and some didn't. That's what our research has shown us. Some people just want the education. Some people want to be accredited. And the industry recognizes that, the need for that. So EPTAC had approached PCEA. PCEA is a nonprofit organization, and they will be the certifying body for the exam. And the exam is an open book, but it's a timed exam. You can look it up in the book. If you can find the answer that quick, you really won't have time to look every answer up. So you really do have to know it. And the ability to, not that you retain every bit of information, but you know how to find it, is part of the action of the exam. We can teach a knowledge base, not a proficiency. Proficiency would be required to be a master of the CAD tool. In that case, take Altium Essentials. So I'm plugging Altium Essentials. It's a great course. The class would be a 40-hour, like I said, lectured with an exam, which is online. And then it will also be offered in the evenings. Many professionals just can't take a week off. So we're offering it over a course of, or the extension of 1 month. So it'd be 3 nights a week, 3 hours, 13 sessions for a cumulative 40 hours. I believe they're offering it for $29.95 or something to that effect. And again, the exam, I think there's an optional fee of $100, $150. I don't know what that is. It's just to facilitate the exam portion of it. So I apologize. I'm not trying to be salesy. I'm just trying to provide information. But we want people to take the class and be able to ask an expert when they're taking it. We have 10 instructors that are regionally across the United States. And so again, when we get back to going live or online, it's time zone relative. So that's.
Rick, you have anything to add to that?
Do I? No, not really. I think Mike hit it all. I mean, it's a proctored course, and there is an optional certification for people who want it. A lot of people want certification because their companies want them to have initials after their name to show that, yeah, we have people with this and that education, and that's fine. I mean, I think that's great. Mike, isn't this also going to be offered as a text to some universities?
So, yeah, and I know Judy said she was going to ask something about it. So I think you literally just are taking her next segue. So I think Judy wants an alternate host for the podcast. I'm not sure.
I am totally down for Rick being the host of the
I'm Judy
podcast.
I just recruited you, Rick.
Thanks.
So,
well, I think so as far as I agree with you, Rick, that's what we hear from our users as well, is that, just like the CID, it sort of lends weight to say, I've accomplished this level of knowledge. And it seems to me, I think there's value in CID. I think there's huge value in what you're doing. Can you talk about who might want to just do CID and who might, or maybe what the differences are, not to disparage CID in any ways. There's value there. So that are more related to, I think, IPC standards and things like that. So
sure.
Can you clear that up?
I can, because I still serve as a CID instructor. The CID, so just going to share a little bit about the two curriculums. The CID was created in 1993. So it's not as contemporary perhaps as this one created in 2021. So that is one factor. The CID is a two-part curriculum that you get over basically the time span of a year, and it would cost more money. But the CID was originally designed to take an existing designer and teach them about standards and manufacturing.
Okay.
And it does a really good job of that. And the advanced CID Plus also teaches you about standards and manufacturing. But I actually got to work with Rick in 2015. And Rick spent a lot of times coaching me and going, Mike. And we put a lot of, so I'm going to say, some signal integrity and EMI constructs in there and some application. I think we've taken that to a whole new level. And again, I say that because Rick has contributed an entire chapter 7 to advanced signal integrity and EMI issues. So, I mean, it's kind of a long answer between the two of them. This one is truly geared towards the new engineering layout person, whoever that may be, that wants to truly become a layout person and wants to augment what they perhaps didn't get in college, which to segue to, so both of them are basically complete type courses. We just feel this is more contemporary and geared more toward making it an engineering layout person. Mm-hmm. And I wanted to segue into the subject that Rick started about universities.
Yes, let's jump in there. That was my next question. So you can also be the next host. I'll just sit here, you guys. Just take over. I'm going to go get a cup of coffee.
Sure thing. Yeah, we'll see you when you get back.
Right. I think this is kind of like my wife who is always looking for the proverbial mute button on Mikey.
Yeah, that's right.
She hits fast forward and she doesn't like it. Or slow-mo. The university, we considered, and we've approached quite a few universities now on this, and we have very good traction. I'm not going to state any names at this point until some license agreements are inked, but this will be available to universities. Let me clarify that. This would be a student who's truly in a 4-year BSEE or computer science type of program. It's a matriculated student. This will not be available to a community college. Okay, we've made a distinction with that. And the reason being is we truly believe that most of the professors we've talked to have said that we feel that this is an elective for a 4th-year engineering degree. It's truly something you would take that would make you a specialist, so that if 2 engineers are applying to go to a Fortune 100 company and one of them says, I also have a CPCD, a Certified Printed Circuit Design certification, which you can obtain through the university, you're more employable.
You bet.
And so it'll be offered for free to the universities. The students have to buy the book. Okay. And the book is not available for resale. We really don't want to just have people get the book and do it. We truly want to back it up with the instructor-led review to truly impart the education portion of it.
So do you see from the professors you're talking about that they would indeed create it as a course as instead of offering it sort of as an elective or through their labs? Because I've seen some universities do that where they want to learn PCB, but they might do it through a lab professor or as an elective to supplement that they do after hours. What's your take on that?
No, they're truly talking about putting it right into their academic calendar.
Okay.
They're slotting it as a 401, 402 type of class or 403. Truly to be over. Some of them have looked at it and saying this is a half-year course, or they want to do it over a full year and breaking it up. There are lab exercises that are at the end of each chapter. And, we're eager to partner with yourself. And I think other CAD companies might take advantage of this. I know you've expressed a great interest of, providing training licenses to college students.
Yep, we do.
We're all for it. You're going to empower them. And that's the one piece we do not bring, is that's the proficiency at a CAD tool.
Right.
Right. Well, Altium already gives away free licenses to students. So
And that's what I'm saying.
that's a
is
nice thing. It's a
Right.
nice, they would fit together well. And I think some other CAD companies do that as well, or have some kind of academic program.
Right. And we're hoping that this has both the curriculum and the labs whereby they can, exercise much of what you have along with, the CAD training you have. And the other thing that the feedback we've received from the universities we've talked to is that their observation of our chapter 7, which again, Rick is the primary author of that, essentially is the equivalent of a master's degree type of curriculum. And this could be taught over a very elongated period of time. Rick's done a fantastic job of condensing it and putting it into our chapter 7. And so it's, I don't really want to call it an appendix or anything like that, but essentially it's an optional chapter on the back end of this curriculum.
Yeah.
So
For
Rick, is there
people who
anything?
want to expand their knowledge in that area. And the truth is, if it were going to be taught as a master's program, it would have to be expanded. As Mike said, I did condense it, but the fact is the knowledge is there for the taking.
Any
Which
other
is-
paragraphs you'd offer on chapter 7, Rick, or?
No, not really. I think it's all been said. I mean, it really is just a condensed form of signal integrity and to some degree EMI control within a printed circuit board. It gets into literally everything you need to know, impedance control, how and why you do it. I mean, the reasons for it, various layout techniques for both RF and digital circuits, a host of things, crosstalk,
Right.
VCC ground bounce, a whole range of topics
Right.
that affect board operation.
One of the perspectives, and Rick and I have had this discussion now, truly, I can recall 6 years, and I'm very grateful to Rick's coaching, as many individuals are in our industry. But a paragraph Rick and I have always shared is there's theory and there's application.
Right.
And there's a whole lot of theory out there, but how do you truly apply it? Because if you
Right.
just conceptualize the theory and you do not know how to apply it, both from the theoretical, to the simulation, to the actual layout implementation, and then further into the manufacturing, because manufacturing can undo some of the best application you put into your layout if you're not careful. So
You
Right.
bet.
we've attempted to add this perspective throughout the entire book, but the theoretical is covered in chapter 7.
Right.
Well, I love that you guys have taken this holistic approach. We've all suffered at the hands of this not being addressed as a holistic subject.
Right.
And, I've been on the fabrication, worked with engineers on the fabrication side and all those disconnects, and I have all the scars to prove it. And it's painful. It's really, really painful. And, Mike, you've been a PCB janitor in your own right. And Rick, you've been, teaching these courses, and every time you do, people come out and said, I never knew, so I think we've both had a different angle on the same subject. But again, I really am celebrating with you, and thank you so much for creating this course, for making this available, for really filling a profound need in the industry. And I wish you both your best of luck. And thank you so much for coming on and sharing this with our listeners.
Thank you for having us. It's
Yeah,
our
thank you
pleasure.
very much for having us. Yeah.
So any closing remarks before I let you gentlemen go?
Rick, you first.
No, I'm fine. I think I've said what I wanted to say. How about you, Mike?
Mikey's never at a shortage for words. I'm very grateful for having us on, Judy. Thank you very much. And Rick, always a privilege to stand by your side in this. I truly, this has been an effort of passion by all the authors,
Yes.
truly to help the industry. It's not a big money maker. This is truly meant to carry into the next generation of layout engineers. We believe it's very contemporary. We believe it's A to Z, and we believe it's going to empower you to, one, be more employable, and two, to be more successful when you have your job. So thank you, Judy.
It's always my pleasure, you guys. I'm fans, and to say it like my friend John Watson said is, You don't want to experience the walk of shame down the hallway to your manager's office to go, it doesn't work.
Right.
Oh, I've been there, and that's an awful feeling. It really is. It's a horrible feeling.
Horrible feeling. Yeah.
Making revision 1 work in the engineering layout world is known as a walk-off game-winning home run.
Yeah, let's do more of that and less of the other. So, well, thank you guys again for joining us. For our listeners, I've put some links below for you in the show notes where you can go take a look at the EBTAC website where you can sign up and register with or without the certification with PCEA. Also, I encourage you to join the PCEA, the Printed Circuit Engineering Association. Wonderful, wonderful association where you can network with your peers, with experts like Rick and Mike. They have regional groups that eventually will meet in person or online. And this also will enhance your career in such a big way. And it's free, or, if you want to give a donation to support them, you can. So I'm going to also put that in the show notes below.
Another thing on PCEA, there are chapters forming all over the country, and for that matter, all over the world. There's a recent chapter in Michigan, up in the Grand Rapids area. And
with my buddy Dugan.
That's Dugan. Yes,
Yeah.
you bet. They're going to be having meetings. I don't know how often, every couple months or whatever, but I'll be the speaker for their next meeting.
Nice.
Oh,
And
that's great news.
We're going to talk about controlled impedance and routing controlled impedance boards. So anybody who's interested in that, go to the PCEA website and have a look.
Yeah, there's so to give the shout out, I mean, Zach Peterson and a handful of other people up in the Portland area. That's an exciting new chapter. Right. There's an incredibly growing chapter, and there's one now in Minneapolis, St. Paul, and also in Ontario, Canada. Thomas Chester, who was, I think, just on your podcast.
He was.
He's there. And then we've got one now in the UK, starting up. We met him through Altium Live, Jesus Castain.
No, Castanier.
Castanier, yeah. Wow. He always lets me slide. He gives me liberties with his name. Jesus, God bless him. And some in Mexico now. We have 2 chapters in Mexico. So
wonderful.
Yeah, let's start a chapter in your area.
Yeah. So really good point. I'm glad we circled back on that. Yeah. So again, the link to PCEA is in the show notes. Go take a look, either join a chapter or start one, you guys. This is kind of a movement right now that we're really enjoying as as old folks. We're just trying to pass a baton and to get all these young men and women, these scrappers out there.
And there are existing chapters in California. There's a chapter Judy's in Orange County.
And San Diego.
San Diego, sorry.
And Silicon Valley.
I'm in both. I'm in that one too.
Oh, there is San Diego and Orange County. That's correct. Yeah.
And Silicon Valley. So I'm in all 3. Right. So I like it so much. Yes.
There are quite a few chapters that people can join.
Yeah. So anyways, there's the plug for PCEA. Thanks for joining us today. Make sure to make your way over to the show notes, and I'll also put Rick and Mike's LinkedIn profile below so you can interact with them on LinkedIn. So thanks for joining us again. We'll see you next week. Until then, remember to stay healthy, stay safe, and always remember to stay on track.